All right, guys. I have a real quick announcement. I was asked to promote this. This is a Q&A with the mayor and the city council chairman. There's donuts, okay? It's a town hall discussion it's on April 6th, which should be Saturday morning, okay? It's all high schoolers are welcome. Today's town hall for tomorrow's future. If you need more information, I can print one out or something. But Penelope asked me to let y'all know about that. So today we're going to talk about probability distributions, finding binomial probabilities, and calculating them on your calculator. Tomorrow we're going to do expected values. A lot of new stuff in this section, so I'm splitting it over 2 days. Okay, binomial probability is in an experiment where there are only 2 outcomes, like success and failure. Okay, now 2 outcomes sounds like, for example, a multiple choice question wouldn't work because there's 5 different choices maybe, or 4 different choices. But when you're looking at it as I either got it right or wrong, there's 2 different outcomes, okay? We're going to use this, what's called the binomial theorem, and we'll use it later to do Pascal's triangle, but for today we're just going to use it to do probability questions. It uses combinations. Remember we talked about combinations yesterday. So it says for n independent trials of an experiment, if the probability of success is p, then the probability of failure would be 1 minus p. Does that make sense to everybody? If you have a 30% chance of success, you have a 70% chance of failure, right? The other thing you need to know here is that X is going to be the number of successes you want in those n trials. So n is number of trials, p is probability of success, q is probability of failure, and x is the number of successes you want to get. It is on your reference sheet. You picked that up one day this week. I don't know. Yeah, was it green? It's on there, just so you know it's on there, okay? I'm going to teach you how to do it on the calculator, and that is also on there as far as where to look on the calculator, okay? Now, here we go. We're ready to try this already. Let's do one by hand with this fancy, ugly formula, and then I'll show you how to do it on the calculator. We're going to use the calculator either way, but so someone all right, I was going to write it down here, but maybe I should just copy it here. Can I just copy that? Oh, I can. What do you know? All right, so this is what we're going for. It says a golfer can drive a ball to the fairway about 70% of the time. What is the probability of hitting the fairway on exactly 14 of 18 holes? Thanks. Keaton and Avon. This one is not me. It has a different room number on. You just handed me too many. Like the post lady who gives my mail, my neighbor my mail, right? These are here. It says a golfer. Okay, so we want to hit the fairway. What's our chance of success? 70% or 0.7. What's our chance of failure then? 30% or 0.3. What do we want to do for success? How many times? 14 out of 18. So this is going to be 14 out of 18. So n is 14, x is 18. So we would have 14's the, pretty sure I have that backwards. Pretty sure I have that backwards. Let's go back and look at what those stand for. N is number of trials. Yep. Because it doesn't work on the calculator unless you put a bigger number in first. So sorry, I totally wrote those backwards. Good thing I'm videoing, huh? The number of trials is 18. The number of successes is 14. All right, so this means the number of ways that it can happen where order doesn't matter, where we can be successful 14 out of 18 times. Just trying to interpret what this means. Then this means we are successful 14 times, and we fail how many times? 4. Okay? Because now does it make sense? This is probability of success to the 14th and probability of failure 4 times because we got to subtract those. All right. So let's do this the long complicated way, which is to type all that in. Do you remember where the C is? Combinations? Yeah, you can do alpha window. I'm going to do it the long way. Math over to probability. Choice 3 because we're doing combinations. And it was 18 and 14. Yeah, I did push the wrong thing. So we have that number. And we're supposed to take that number, whoops, 3060, is that right? Is that what you got? Times 0.7 to the 14th times 0.3 to the 4th. Anybody getting that? All right. Ready to learn the really easy peasy way to do this? Is everybody getting that? Anybody got a question? All right. The calculator will do binomial probability for us. Okay? So it's where that other normal distribution stuff was, normal probability. So we're going to do second vars. But we have to scroll down all the way until we find binomial probability. Now, it's a little bit tricky because we have to decide, is it exactly or all of? Was this exactly 14 of 18? Is that what it was? Okay, it's actually a PDF then, binomial PDF. And I'll talk about that more in a second. And it says here the number of trials. What was our number of trials? 18. The P is the probability of success, which was 0.7. X is how many we want to get right. We want to be successful, so that was 14. Yes? Same number? Everybody okay? You need me to go through it one more time? You make sure you picked the PDF, not the CDF. We're going to talk about that in a second. Okay, so the probability of success exactly 14 of 18 times is found using this fancy formula or using binomial probability distribution function, PDF. Okay. So the probability is what, 16.8? Is that what we got, guys? So you could answer the probability is either 0.168 or 16.8%. probability that we would hit exactly 14 of 18. All right, let's see if we have one more that's this way. The probability that a substitute teacher has to work on a Friday during any given week in a certain school district is 32%. What is the probability that the substitute teacher will work on 3 of the 4 Fridays in the upcoming month? Okay, so what is our 32%? What is that representing? Yeah, that's the probability of success for this question, right? So what's the probability of failure? Sounds right. Yep. What is the probability that she will be successful working 3 out of 4 Fridays? So we want the total number of trials to be 4 and the number of our successes to be 3. We're going to cheat and do this the other way, but let me write it out this way one more time. 4C3, 32% of the time she wants to succeed, which would be 3 successes. How many failures then? If she wants to work 3 out of 4, 1 failure. Okay, so we could do it that way. If we're doing it Binomial PDF, we are going to put in, what does it ask for first? Number of trials, and then probability, 0.32, and then number of successes, I think is what it's going to ask. All right. I'm just going to go directly to the Binomial PDF. I think it's a little faster if you go this way, but anyway. So 4 trials, was it 0.32, guys? And what's the chance she works 3 of them? Anybody get that? 0.089? Did anybody try it the other way? Yeah. And it worked and got the same thing? Okay. All right, so now I don't have it up anymore. 0.089, is that right? About 8.9% is the probability that she will have to work 3 out of the 4 Fridays. All right. It gets more complicated. Surprise, surprise. This question says, on average, a basketball player misses 3 free throws out of every 8 attempts. Okay. We got to use that to find our probability of success or failure. What is 3 out of 8? Is that success or failure? Yeah, misses 3 out of 8. If the player attempts 5 free throws, what is the probability that he misses no more than 2 times? Oh, this is confusing me. Okay. Let's do success. Okay, what's the chance that he is successful and makes a basket? 5 out of 8, or if we enter it as a decimal, okay, the chance he misses is 3 out of 8, or point. Thank you. If the player attempts 5 free throws, so we know that 5 is what? Number of trials. What is the probability that he misses no more than 2? Okay, so how many times do we want him to succeed? Okay, 3 or 4 or 5. We're going to have to do 3 of these and add them up. Okay, so what's the chance that he makes it, misses no more than 2? So he could make 3, 4, or 5. And then I'm going to show you another way to do this. But all right, this is probably the way that will be more comfortable to start with. So let's go ahead and use the Binomial PDF. Is it It's A. I never get there by that. Okay. Trials was 5. Success point 625. And we're going to start with 3 times he makes it. Okay. Then I'm going to cheat. Does anybody know how to cheat and make this easier? If you scroll up here and just hit enter, what do I want to change? The 3 to 4 times. You can retype it, it doesn't matter. And then I want to scroll up and say, well, what if he was successful 5 times? All right, now what do I want to do? Yes. So I'm actually going to move this onto here so that my notes have some numbers here. This one was 0.343, is that right? And the second one was 0.286 and 0.095. So if I add those all up, which I could do on my calculator, yeah, you guys just typing them in is probably faster. 0.7245, something like that, depending whether you used all the decimals. But about 72%. Can we just go with that? Oh, well, my circle just messed up my whole answer. Ugh. All right. Print these slides. I want this here maybe. Okay. So what's the probability that he misses no more than 2 times? About 72%. Now, there's another way to do this, but the calculator, you can tell it to combine all those probabilities for you so that you don't have to do that 3 different times. But the calculator combines down. So it will not go up as in 3 successes, 4 successes, 5 successes. Okay. So we would have to do 1 minus the chance that he missed no more than 2 times. I'll show you. We won't do it this way this time. We'll see if there's another example we can do this on later. What you would do, I think I can get this right. You would say, what is the chance? And you would use this CDF, okay? What is the chance out of, was it 5 trials, guys? With successive failure, 625? No, success. That's success, right? Okay, I said the right thing. I think I said failure. Chance of success. And we want him to succeed 3, 4, or 5, but I want to know what is the chance that he succeeds 2 or less times, because it counts down, 2, 1, 0. So if I put in a 2 here, it's going to add up the probability that he only gets 2 or 1 or 0, and that's not going to be my answer, because I want to know 1 minus that answer, because I don't want to know that he misses, I want to know that he makes it. Is that what we had, 0.724? Okay, but that was complicated to think about, right? So if you're counting up and it's not too many, you might want to just add them up. You can always use PDF. You just might have to keep using it multiple times to add up all the probabilities. CDF combines, but it always counts down. So we'll do more examples. Let's just keep going here. You have these assigned tonight for homework, okay? And those are pretty straightforward. And now I'm moving on to the next page, I think, or is he at the other side? Next page. Okay, the next page actually is going to talk about probability distributions, and when we did this last year, we did it in different order, so we had to go back over like what's a mean, median, mode, and standard deviation. Does everybody remember how to find those on your calculator? If you put a list of numbers in, okay? If you put a list of numbers in your calculator and you wanted to find, like, I'm just going to use my little list here. This is a number, this is numbers for a question later. But if I wanted to find mean, median, mode, and standard distribution of this list number 2 right here, I would go stat, right arrow, one variable, and I'd tell it what list I was doing. And then we have not used frequency list yet. And then calculate. Do you remember doing this now? Anyone? Okay, this is the mean X bar. Yes, we did. The standard deviation we have used so far is the population one, which is this guy. Okay. And then N is the number of items, and then we had the 5-number summary. Is this coming back to you now? Okay. All right. We have also, all right, so X bar was a mean. We have also talked about this. This is just another symbol they use for mean when we're talking normal distributions. Just wanted to remind you of that. All right. The measure of spread or variation is how far the data is spread out. We have talked about this. We used standard deviation, okay, and that's found on the calculator. There are formulas for finding standard deviation. I explained this before, but our calculator is just going to do it for us. But you would take every number on your list, subtract the mean, square those so that you have only positive numbers, then add them up, which is the sum symbol here, and then divide by how many items there are. Or if it's considered a sample, you would divide by 1 less than the number of items, and then you would square root back to get a number that's on your list or appropriate for your list. Okay, so it's fancy, but the calculator does it for us. All right, here's a quick question, and I'm not going to ask you to type all these in, but it says the quiz scores for 25 students are shown. Find the range. So you would have to find the highest minus the lowest. What do you think? 10 and, oh, there's a 2. I didn't see the 2. 10 minus 2. Okay. Find the mean. So you'd type them all in and divide by 25 because it said there was 25 of them, right? Or the calculator would divide for us. So the mean was about 7.4. If you wanted to find the variance or the standard deviation, again, you could do it on the calculator. Looks like it, I don't know, it's cut off here at the bottom, but the calculator would do it for you. It looks like the standard deviation was, does it say on this slide? Oh, 2.1, okay? And this is a reminder that for most things, the majority of values fall within one standard deviation of the mean, and almost all of them fall within 2, okay? If the quiz were compared with other quizzes throughout the country on a nationalized test, you would talk about how many standard deviations you were away. When comparing data sets important to analyze the center and spread, 2 data sets can have totally the same mean, but different spreads or standard deviations, okay? So the same class average on 2 different quizzes doesn't necessarily mean everybody did the same. Okay, one class could have had a lot of A's and a lot of F's, and the other class could have had a whole bunch of C's. So it's just a matter of how that's spread. Do you remember this as well, 5-number summary and doing the box and whiskers? I left these slides in because I want to be reminding you of stuff we did a long time ago before break. Do you remember doing this? Do you remember how to turn that on? Yeah. To see the box and whisker plot? Okay, if you had a set of data in You don't have one necessarily. But if I wanted to go through and turn the box and whisker plot on, it's plot on. Box and whisker is the fourth one over. Let's see, I had those numbers in list 2, I think. And then I would just want to do a zoom stat. Okay, no outliers. Pretty clear there's not going to be too many outliers on a list of numbers from 1 to 10, but all right. Oh, my list of numbers wasn't 1 to 10. Anyway, I didn't put them in, remember? All right, but we remember how to turn it on. That was what I was getting for. All right, new vocabulary. Ready? When we talk about probability distributions, it's going to talk about what's called a random variable, and that concept is really confusing, but basically it represents a numerical value assigned to some kind of an outcome. So if I ask, well, here's some examples. It just says, can take on either a discrete or continuous random variable. For example, if I want to know how many car accidents occurred, it's called discrete because you don't have 0.7 of an accident, right? Anything that has to be listed in whole chunks is called a discrete variable. Anything that can be continuous, like time or height, can be measured to the nearest centimeter or 1/10 of a centimeter or 100th of a centimeter, or anything that you can have fractional parts of is called a continuous random variable. There are, I don't even think we put this on the quiz, honestly, but there are ones that are a little bit tricky. For example, if we did height of basketball players and we went online and we found their height, are they going to quote that to the nearest 1/10 of a centimeter? It's going to be probably 1/2 inch at the most, or maybe rounded to 1 inch every time. So then that could be said to be discrete because we really don't know that they were actually exactly on the half. I would never ask you one that tricky. But if I ask you, how many ice cream cones did you sell today? How's that going to be answered? Yeah, discrete, because it's going to be answered as a whole number, right? Okay. If I asked you the average temperature this week, it could be measured as random or continuous because you could take the temperatures and divide them out and get it like 0.25 or something, right? All right. Again, I don't think I put that on a quiz, but let's go through these examples real quick here. I don't think you have these two. Well, I'll go through these 4. I don't know if you have them. Weight of a cereal box, that's going to be continuous because we could measure it to the nearest, hundredths or whatever. Number of cars in a parking lot, definitely going to answer as a whole number, so discrete. Time it takes to get your food at a fast food restaurant, discrete or continuous? Continuous. Okay, because it could be measured, 7 minutes, 7.1 minutes, how many seconds, you could break it down. Attendance at monthly school board meeting, discrete. There's a whole number of people in the room, right? You have these 2 examples, represents time it takes for the classroom to go from this to this. So time, what do you think? Continuous. We could say 1/2 an hour, we could say 15 minutes, or we could say 3.7 minutes, right? So it's continuous. You could make it smaller and smaller increments of measurement. Number 2 says number of photos taken during a wedding. Discrete, because you either took the photo or you didn't, right? It's a whole number. All right. Moving on, we're going to talk about a probability distribution. Probability distributions is just going to be a little chart that takes all the possibilities and lists the probability of them happening. So it's going to take, for example, the probability that if you're talking about 5 questions on a quiz, what's the probability you guess them all wrong, 1 wrong, 2 wrong, 3 wrong, 4 wrong, 5 wrong. That's it. Those are all the probabilities that can happen. So the distribution has to total 1 when you add up all the probabilities. Okay? So it's just a chart. So what it does, though, is usually works with a frequency table. Are you awake, guys? Got to know frequency here, okay? It says, on a teacher evaluation form, students were asked to rate my explanations, some teachers' explanations, from 1 to 5, where 1 was too simplified and 5 was too technical, okay? So the score was 1 to 5. One student said 1, 8 students gave a 2, 20 students gave a 3, and so on. Okay, frequency. Make sure you understand that. We had a question like that on the SAT packet, remember, where about how many people scored between a 1 and some weird question where it was a frequency table. Like, all right. So there are 50 students if we add these all up. Okay. So to find the probability of each score, one person said 50, so 1 divided by 50. 8 people gave a score of 2, so 8 divided by 50 was 0.16, and so on. And then they put it into a little table. So one person, a score of 1 was given very rarely, but a score of 3 was most often, and 4 was pretty often as well. Everybody good? Because we're going to have to do this in a second, okay? They put it in a little table. All right. The mean of a probability distribution means that you average the scores, basically. Now, if I were to do this, I would have gone back here and put this in list 1 and this in list 2, which I actually did. Okay? You guys want to do this real quick, since it's a nice short list? We haven't done these for a while. Stat, enter 1, 2, 3, 4, 5 in list 1. 1, 8, 20, 16, 5 in list 2. 1, 8, 20, 16, 5. Go up onto the title and then hit clear enter. Or if you just want to delete single items, you hit delete on each one. How we doing? Everybody got them in? Okay, if we want to find the average of these numbers, what we do is we go stat, arrow to the right to one variable stats. Okay, but we now have a frequency list. That's what the second list was, right? So our data is in list 1, but the number of times each of those scores was chosen is now in list 2. Because if we wanted to do this by hand, I just want to make this really clear. If we wanted to do this by hand, we would have to go, or if we wanted to explain this to somebody, you'd have to say, one person gave a score of 1. How many people gave a score of 2? Okay. How many scores would we have to enter if we wanted to do it that way? 50 scores, right? But rather than entering all 50 scores, we're using this frequency list. Okay. So frequency list needs to say list 2. Everybody good about getting where to get that second 2? And then we're just going to calculate. Now, I struggled because this is not the same number the book gave me. Everybody get 3.32? Okay. I was like, what did the book do? Because their answer was... Oh, it was 3.3, I guess. But they had a slightly different, because they rounded them and then averaged from here. Okay? We just did it from the straight up data. Now, what that means is that 3 was the most popular given score to this teacher, but 3.3 was the average score. Okay. So it meant that, well, the explanations were kind of right in the middle, not too technical or too simplified. There was a little bit leaning towards their being too technical. I guess that was high score. All right, I'm just trying to interpret this. We have this question. You ready? Okay. Number of medical tests that 15 randomly selected patients entering a particular hospital received one day. So I stood in the parking lot, asked 15 people when they came out of the hospital, how many tests did you get run today at the hospital? Okay, 6 people said none, 5 people said 1, 3 people said they had to have 2 tests done on them, and 1 person said they had 3 tests run. Okay, we want to change this to a probability distribution. How do we do that? Anybody? How do we change those to a probability? How many people did we ask? 15. So what do we do with each of these numbers? Yeah, probability, 6 out of 15 people said this, so that probability is, let's see, what is it? 5 out of 15 people, 0.3 repeating, right? 3 out of 15 people would be 0.2. And 1 out of 15 people, I don't know. Okay. If we added those all up, including all the decimal places, what's it supposed to add up to again? 1. All right. Everybody good? Yes. 0.4, 0.3 would be 0.7, and 0.2 would be 0.9 if we rounded that to 0.1. You good? All right. The second part says find the mean and interpret it. Okay. I think it would be easier to do it off this original set. So can you put those numbers in real quick? Go to the list. I'm going to put mine in 3 and 4. What is it? 0, 1, 2, 3. Okay, thanks. And then we're going to do the mean. So it's at, right arrow, choice 1. And you probably already have the right list numbers in there, but I don't. Anybody get that? 0.9333? No? Oh. Because it doesn't ask you for a frequency list, right? I don't know if you can type that. Try typing one variable stats, because that do the stat right arrow one variable stats. But then before you hit enter, is there a parenthesis there? Okay. If you go on your home screen, do stat. Let me see if I can turn this off so mine doesn't do that either. So if you go stat right arrow 1, then type, you don't have a parenthesis, you're right, but do second and then like list 1, comma, list 2, but mine are in 3 and 4. See if it does it then. What? Okay, bring it here, let me check it. All right, guys, what does 0.93 mean? Means the average person had test runs. So that really doesn't mean anything to us. Oh, you needed a comma in between, but otherwise, I don't know if it's going to work anyway. Yeah, there is. Here you go. Hey, it worked. All right. The average person had about one test run, right? With it actually leaning towards no test. You can't really say had 0.93 of a test because you can't have 93 of a test, but that's what it's interpreting. Okay, so the mean was 0.93 or average about one test run per patient. Okay, what was the variance or the standard deviation? I really don't care about the variance, but what was the standard deviation? Do you remember what to look for? Do you remember the standard deviation? We have used population or sample. We're just going to stick with population for now, okay? 0.928. So the standard deviation of 0.928. And all that really means is most patients had between, okay, if we went from 0.933 and we went 0.928 one way, we'd be basically at 0, right? If we took 0.93 and we added 0.928, we'd be almost at 2, yes? So had between 0 and 2 tests. Not shocking, right? This was a very small sample size, okay? But we can definitely conclude most people had between 0 and 2. All right. Binomial distribution. Binomial experiments. Okay, we're going to get back to this. This is what we started with today, remember? Binomial probability. We're going to do some more of them. We're going to do the complicated ones where you have to add up. I will start with this tomorrow, but I think that you are okay to work on this. Those 2 questions off 7B for sure. And then 8.5, worksheet 8.5, side B. Did everybody find 8.5? I know we don't usually have 0.5s, but I already had a worksheet 8 and a worksheet 9, so I stuck in 8.5. Okay? Worksheet 8.5, side B, you should be able to do now. I will go over tomorrow the more complicated ones. Everybody good?